Welcome to the Math Building. My name is Gregory Carlson, and today we're going to start an incredible journey. We're going to start learning about calculus, which is my favorite subject in mathematics, because calculus takes all the math you've learned so far and it ties it up into this wonderful bow. And so the first question is to ask, what is calculus? And you can use a lot of different ways to define calculus, but the way I would define it is, when you break it down, calculus is the study of change. It's the study of movement. Specifically, it's the study of mathematical change. And what's really interesting about it is the word calculus actually comes from the Latin, which meaning small stones or pebbles, which, by the way, is why I think a lot of people say calculus is so hard. Oops, get it? But anyway, you might have heard people talk about algebra-based physics or algebra-based economics and versus calculus-based physics or calculus-based economics. And so what's the difference? Well, when you're taking physics or economics that's algebra-based, it's kind of like playing a two-dimensional video game. You can get around, you can move your character around and solve problems, but you're really limited. And what calculus does is it gives you this whole third dimension that you can suddenly move around, you can see the wider landscape, you can have a better understanding of what's going on. And so I'm really excited to go on this journey with you. So what I'm going to do now is just quickly go over all of the subjects we're going to cover and kind of outline the class. And the calculus, as usual, is best thought of as a building. And so the ground that we're going to build our building on is functions, relations, and equations. In a way, calculus is the study of functions and getting more information out of functions, relations, and equations. So that's the ground we're going to be building on, and every building needs a foundation. And the foundation we're going to build for our building is called limits. Limits is how all of this makes sense. And in a way, we're going to be introducing some philosophical questions into this. This is the first math class with some philosophy in it. So limits and continuity. That's going to be our foundation. And when we have limits and continuity, we get these two great uses out of it, these two great applications. And the first is called derivatives. Derivatives are the first, D-E-R-I-V-A-T-I-V-E-S. They're the first great use, and we can represent them with the symbol d over dx, or d dx. And the second great thing we can do with them is integrals. That's the second big application. In a way, calculus is these two topics half and half. And for integrals, we'll write this giant letter S. It's kind of like an S. It looks like this. So we'll write that and write dx inside of it. So we've got derivatives, integrals, dx, and they're both pretty nice. But then once you get far enough, something amazing happens. You find out that derivatives and integrals are two sides of the same coin in something called the fundamental theorem of calculus. Spoiler alerts, by the way, I kind of just spoiled the class a little bit. The fundamental theorem of calculus says that derivatives and integrals are two sides of the same coin, and that to me is just incredible. For a lot of students, this theorem right here is kind of the finish line of their math career, and certainly I think it's an appropriate finish line. But if you want to go further in math, you're going to discover that this class and this information is really just the beginning of a much bigger math journey. And this class is like a gateway to a lot more interesting classes and ideas. So that's what we're going to be learning about in Calculus 1. And I'm really excited to go on this journey with you, and I hope you are too. So let's get started.